Hello friends. Uh, in this tutorial, we are going to study about MATLAB software. MATLAB is a multidisciplinary software and which is used to solve the problems of a different discipline. So here in this video, we will take some overview of the MATLAB, different MATLAB environment. Then we'll discuss its application in the different field of the engineering, and also we'll study the some important matrix operation and how they are used for solving the problems in chemical engineering. MATLAB, it's a short form of Matrix Laboratory, is a fourth generation high-level programming language and interactive environment for numerical computation and visualization and programming. MATLAB is developed by MathWorks. It allows matrix manipulation, plotting of functions, data, implementation of algorithm, creation of user interface, interacting with programs written in other language and including C, C++, Java, and Fortran, analyze their data, develop the algorithms, and create models and applications. It has a numerous built-in functions, commands that helps you in mathematical calculation, generating plots, and performing numerical methods. MATLAB's power of computational mathematics. MATLAB is used in every facet of computational mathematics. Following are some commonly used mathematical calculations where it is used most commonly. It is used in dealing with matrix and arrays, 2D and 3D plotting with graphics, linear algebra, solving algebraic equations, nonlinear functions, statistics, and data analysis. Then also used in calculus and differential equations solving, numerical calculations, solving integral equations, transform, curve fitting, and various other special functions are there in MATLAB. Now we'll talk about MATLAB environment. MATLAB has three basic windows as shown in the next slide, namely MATLAB desktop window, editor window, where we can write, edit, save the program, figure window, which display 2D and 3D graphs of the functions. The MATLAB desktop window itself has three sub-windows, command windows, where we type commands and run the programs. Current directory window, where all the files in the current directory are listed. And the last one is a current command history window, where all the previous commands we typed are recorded, even across the multiple sessions. And if we double click any command in the history window, the command will be executed in the command window. So this is the environment of the MATLAB, where we already discussed. There are different windows. So here is the command window. Then here is this is editor window where we can write, edit our program, and after running the program, we can have the figure or the graph in this form. Right. So this is a environment, and along with this, there is a current directory and the command history window. Now we'll discuss about working with matrix and its vector, and this knowledge will use in solving the chemical engineering problem in linear algebraic equations. MATLAB works with essentially only one kind of objects, that is a rectangular numerical matrix with possibly complex entries. All variables are represent matrix. If you want to store matrix in a variable A in MATLAB's current memory, you type the following in the MATLAB command prompt. So this is a matrix which we want to form. Then in command window, we have to type this matrix A in the form of like this, where A, this is the command prompt, and we have to write this matrix in the form of A. So A is nothing but having these different rows which are having the elements 1, 2, 3. This is the first row, 4, 5, 6, second row, 7, 8, 9. This is the third row. Now, if we use this in a MATLAB environment, you can see. So here is a command window, and this is editor window. This is editor window, and here is the current folder, and this is a workspace, and these are all the different functions or the menus available in the MATLAB. So here, to form any matrix, we use in this command prompt. Suppose we want to display matrix A is equals to, and it should be right in square bracket only. So it will be 1 space 2 space 3. Now the two rows can be differentiate with semicolon, which is very important. Then again 4 space 5 space 6. Then again semicolon, and 7, 8 and 9. Then close the bracket. Then you can have this matrix A, where this is a 3 by 3 matrix. Okay. Then now, uh, as we appear this matrix A is equal to this 1 2 3 first row, 4 5 6 7 second, 7 8 9 third row. Now these rows are separated by semicolon, as we already discussed. Two rows are separated by semicolon, and the elements are separated by space, or uh, it may be separated by comma. So that is, our matrix can also be stored by this command. That is, A is equal to 1 comma 2 comma 3 semicolon 4 5 6 semicolon 7 8 9. Okay. Now if you see, if we write this column, this matrix in command window, we'll have A is equals to 1 comma 2 comma 3, then semicolon 4 comma 5 comma 6 semicolon 7 comma 8 comma 9 bracket complete. And if we give semicolon, let's see what will happen. So here there is a use of this semicolon. What is the use of this semicolon? You can see here, the semicolon at the end of the command suppresses the output. That means even though there is a matrix A with these elements, but that matrix is stored in the MATLAB, but it is not executed. It is not executed. So what will happen if you see same function or same matrix will be written here, and we remove this semicolon, then we'll see what will be the change. Yes, now we will have this matrix A appear here, display here. So this semicolon suppress the output. Now the matrix A is transpose and is stored in B by a following command. So what is the command? B is equals to A transpose. Then we'll see what will be the change. B is equals to A transpose. So we'll have that elements get transpose. They are get the vector column and rows are get change. You can see here. So this is the command. This A dash is the command for transpose. And we will have the B matrix in the form like this. Now there are different matrix operation that are used for solving the problem, like plus, addition, that is minus, subtraction, multiplication, for doing all these arithmetic operation by a different matrix, right? So we have A and B two matrix. We can add them, we can subtract them, we can multiply them, we can take the power of that matrix, right? We can have a division. But to have the operation above, these above listed only if that are possible if the matrices are compatible for such operation. Their number and rows should be compatible, should match for the operation. Then only we will have the results. Otherwise, we can have the errors. Now, this table shows some of the important function dealing with the matrices. So we know we can we require a lot of time to solve the matrix, forming the normal of the matrix, then norms of the matrix, rank, determinants, subspaces, eigenvalues, eigenvector, size, traces, null matrix, orthogonal matrix. These are inverse of the matrix, right? So these are all the functions, and we can find out the values or these functions by just giving uh, this command in the MATLAB command window. We'll see. Suppose we want to find out the determinant of the matrix, then we'll see what will happen. Suppose we want to find determinant of A. So B is equals to determinant of A. Look what will get the answer. Yes, this is the determinant of A, right? If we want to find the rank of A, then suppose rank of A, can check the command. What is the command for rank of A? Rank of A, right? To find the rank, matrix rank, we'll have rank of A. We'll get this answer. Rank of A is 2. Similarly, if we want to find eigen values of the A, then we'll have the command EIG of A, and it also gives us the different options available to find the eigen values. So these are the eigen values, right, for matrix A. Then we can also find the different functions. Now we are going to use the inverse of the A, because this inverse function we are going to use to solve the problems in the coming practical. So suppose C is equals to inverse of A, INV of A. It gives the answer. Yes, actually, this matrix is very close to singular or badly scaled. That's why we get the answer. But this is not the proper, or results may be inaccurate. But if we take the another example, we will not get this warning, right? So in this way, we can get the inverse of the matrix by using just inverse command. Now there are other commands also, other syntax also, well, which we have to use. That are we'll see in the next slide. So matrix matrices and the column notation. So consider a matrix A given by. Now suppose we have another matrix A is equals to 1 2 3 4 5 4 6 7 1, and this 2 3 4 5 again. Right? We'll use this matrix again. We can remove all these or we can clear this window by using the command CLC. It removes the command. So A is equals to, in square bracket, in square bracket 1 comma 2 comma 3 comma 4, semicolon, 5 6 7 and 1, semicolon, 2 3 4 5. Now we have this matrix. Okay, now what we have to find for this matrix, let's see. We have this matrix, then we want the vector consisting of three third column of A only. So this is the matrix A, and we want only this third column of this matrix, right? For the further calculation. Then how to select only this third matrix, third column from this entire A? So this is by B is equal to A colon 3. So this is the way for selecting third column of matrix A, third column of matrix A. We'll see the its effect. B is equals to A of colon 3, right? But we have to write comma also. We have to write comma between these two, and we'll see the results. So here we can have D is nothing but 374. This is the column, third column, elements from the third column. Similarly, we can have another operation, that is on C is equals to third row of A, third row. So this is the third row. So we should have to select, or we have to choose these 3, 2, 3, 4, 5, these elements for the further calculations. Then how it can be selected? So in this way, the column will be shifted to this position, and we have to select third row of A. So here you can see C is equals to A, round bracket, third row of, right? You can see once again, right? A in round bracket. So we'll see the results. Yes, we have this 2, 3, 4, 5. So C is equals to these elements. So we can get this another matrix or the vector. Now we'll also see the another, that is D is equal to A end. End means the last row. This is for row, right? If end will be here, then this will be for column, last column, right? So we'll see this change. D is equals to A end, right? 2, 3, 4, 5. So by using the same, we have get the same value, because we have this third row only. If we have fourth row, then this answer here will have the element will have from the fourth row, right? Now another E is equals to A of 1 to 2 and 3. So here this command tells us vector consisting of first two entries of third column. So this is the third column, this is the third column, and we want two entries only. That means 3 and 7. 3 and 7. So E is nothing but the vector which should contains 3 and 7. So how it should write like this. E is equals to A in round bracket 1 comma colon 2 comma 3. So E is equals to A of 1 colon 2 comma 3, right? So we'll have same 3 and 7, right? 3 and 7, these two elements from third column, right? Now we can also have this D is equal to first two rows, only first two rows, that means these two rows. So D is the vector for these two rows. What will happen? We'll see. D is equals to A of 1, 2, right? So we'll have this first two row only. You can see here, these are the first two row, 1 and 5. So we'll have 1, 5, this first two row. Now, these are the some of the matrix operation which we are going to use in the uh, uh, next problem, in which we are going to solve a linear algebraic equation by using this matrix operation.